Some of you might have noticed in the recording for the past video they've missed out part C, so we're going to have a quick little go at having a go at part C. Part C gives us these two shapes, point P and point Q, and asks us to find some times when Q is a certain position relative to P. Notice it says of P, so P is the one we're going to put at the origin. So what I've done is I've copied my PQ, so this is how I get from P to Q, and it depends on time t. Notice my I and j's are underlined because these are my component vectors. Over here I've got a little set of axes, and what I want to know, if I start at my point P and head off along PQ, when am I, for the first bit it asked me when am I due north of P. That means I want to know when is Q up here somewhere. Before I start, I need to decide what vector takes me from P here up to Q. And if Q is due north, we're just going up this way, which is in the direction of the vector j. So vector j takes us upwards, so we want to just go in the vector j, but we don't know how far this is. So due north over here, I'm going to make a note of this. It's the vector j, but it could be any amount of vector j, so I'm going to put k j. So k lots of vector j. So k could be 3 or 4 or 5 or 10 or 15. Any value here makes us go in the j direction, and it goes upwards or towards north. The only thing we do have to make sure is that k is greater than 0, because if k were less than 0, we'd be going like minus 3j. That would mean we were going south. So what we're going to do is we're going to take this PQ and we're going to set this equal to kj to make sure that we go due north. So I'm going to write out my minus I minus 3j here, plus t lots of I plus 7j, and I'm going to make this equal to kj. In order to work out the value of t from this, we need to first look at the I component. So if I look at the i's, I've got minus 1 here, I've got t here, so plus t, and I've got 0 on this side. I've got no i's on this side. If we look at the j component now, my j component, if I look at the j's, I've got minus 3 here. Here I've got 7t, from 7 times j times t, so it's 7t. And this is going to equal k. So from these we should be able to work out the value of t and the value of k. So if I take my equation here, I can rearrange it so I get t equals 1. And if I put t equals 1 into here, I get k equals 7 take away 3, which gives us 4. So this means at t equals 1, pq, which is a vector, which is the one that takes us from P up to Q, is the vector 4j. We know it's 4j because it's k times j, and we worked out that k is 4. So this 4j takes us due north. So the actual answer, find the time when, is t equals 1. If we go back to the question just to make sure we have answered it completely correctly, it asks in the question, t is in hours, so I guess it's 1 hour after the start time. It's after 2 p.m. So it's 1 hour after 2 p.m. So this is going to make it 3 p.m. So at 3 p.m. it is 4 kilometers due north of due north of P. For the second bit, we're asked when Q is northeast of P. So if I draw another little mini set of axes over here, and I put P in the middle. So when Q is northeast, so northwest, which is up over here, this is where Q is. So we want to go this way. So this vector is actually minus ki plus kj. Because we want to move at 45 degrees, so we want to go the same amount along and the same amount up. But we're going backwards in the I direction, upwards in the j direction. So this is our vector for northwest. We're going to do exactly the same as we did before. We're going to take our PQ that we discovered earlier on in the question, and we're going to set this equal to our northeast vector, and then we're going to find out the value of k. So we're going to take our thing from over here, so we get minus I minus 3j plus t I plus 7j, and we're going to set this equal to minus k I plus kj, because this is just a vector in the northwesterly direction. Again, we're going to make an I equation. For the I components, this gives us minus 1 plus t equals minus k, and over here we get j. For a j equation, we get minus 3 plus 7t equals k. So now we just need to find the values of t and the values of k from this. Because I'm after the value of time, I'm actually going to eliminate k. So I'm going to make this one here k equals, so I'm taking the minus over, so I get t minus t plus 1. So I'm going to put this over here, so I get minus 3 plus 7t equals minus t plus 1. So if I take this over, I get 8t equals, and I add this 3 over, I get 4. I get t equals 1/2. So this is at 2:30 p.m. Because t is measured in hours, it's half an hour after the start time, which in the question it gives us start time. It says at 2 p.m. the ship is at this position, and t is measured in hours after 2 p.m. So it's half an hour after 2 p.m, which gives us 2:30, and that's the end of the question.